Hello, I'm Param Singh. Hope you guys are doing well. In the last few videos, we learned about our first complex data type called tuples and noted that tuples are a good fit for modeling compound data of fixed size. So, when the number of elements that go together is known, then tuples are a good fit. On the other hand, we want to model a compound data of arbitrary size. That's when lists are a good fit. For example, a to-do list. So a to-do list could be empty if you have nothing on your agenda. On the other hand, a to-do list can also contain one or more items, and the size can vary depending upon how many tasks you have to finish or you want to finish. And as you progress through the day, you can add more tasks to it or cross off the tasks that have been done. So the size is varying, and that's what we mean by arbitrary size. Another example is list of your favorite college basketball teams or list of students signing up for a field trip. So how do we construct a list? We start a square bracket, add our element, and then put a comma, add another element, and then finish the list with the closing square bracket. For example, here we have a list of 3 elements, the numbers 1, 2, 3. In the next example, we have a list of 2 elements, the colors red and blue. More formally, let's look at how the list is defined because it has quite important consequences on how we write our programs that consume the list. So we say the list is either empty list, which is represented by square brackets with no elements in them, or one element and joined with, so this is the join operator, another list. So either it is an empty list or it is a pair of, we call this first element head, the second part of the list, which is a list itself, a tail. So either it is an empty list or it is a pair of head and another list. This is very interesting that we are defining a list, but in the definition itself, we are saying it is composed of another list. So whenever you see a data definition where name of the data itself is referenced inside the definition, these are called self-reference types of data. The reason I'm emphasizing this point here is because when we construct a list, we are usually not going to construct a list with the fixed number of elements. We are typically going to either add or remove elements to quote unquote recursively build the list. So we'll see in the examples in the next few videos on how this definition helps us out in consuming list data in our functions. So here are some formal type definition examples. You could have a list of string represented by a string inside square brackets. You could have a list of pair of numbers. So here the single element itself is a pair represented by 2 numbers inside a tuple. Or you could have a list of pair of an atom or a string. You could think of this as a use case of some data coming from an API, and that atom could be okay or error depending upon if the data call is successful or not, and then the string will contain corresponding data. So once we know how to construct a list, we also need to learn how to select the elements of the list, and once again pattern matching is going to help us. So let's look at few cases, and then we are going to run these cases in our IEX environment to do some more practice. So the first case, the pattern is an empty list. It matches on the right hand side the value of an empty list. The second example, we are now taking up the definition here itself. So the left hand side pattern is one element and then joined with another element, and not the element, with another list, and this will match this list of 1 2 3 and will bind the variable head to the element 1, and then the variable tail will be bound to a list of two elements 2 and 3. So TL will be bound to 2 3 list, whereas HD will be bound to 1. The third example is similar, but we discard the head, and TL will be bound to the list of 2 and 3. In the fourth example, we discard the tail of the list. So the list 2 and 3 is discarded, and HD will be bound to the element 1. In the next example, we are pattern matching the number of elements. So we have 3 element list on the left hand side, we have 3 element list on the right hand side. So X, Y, and Z will be bound to the values 1, 2, and 3 respectively. In the next example, we have a 2 element list on the left hand side, but a 3 element list on the right hand side. So this of course will result in a match error. Similarly, the last example has an empty list on the left hand side and a 3 element list on the right hand side. So this again will result in a match error. So now let's go to our IEX console and run some of these pattern matches so we understand them better. So for that, let's first create a list of simple 1 2 3 elements there. So we have a list of 3 numbers 1 2 and 3. So one thing you could do is you could match an empty list to an empty list, and this will match, but no variables are bound. On the other hand, we could match the head of the list joined with the tail of the list to this list, and now head will be bound to the element 1, whereas tail will be bound to a list containing the elements 2 and 3. If we don't want either head or tail, we can use the underscore to discard those values. For example, here we are saying we'll match this with the list, but we'll only bind the TL variable to the list 2 and 3. So TL will be bound to the list 2 and 3, whereas head will be discarded. On the other hand, you can take the head and discard the tail, and here head will be bound to the first element, which is 1, whereas the list tail will be discarded. Let's see how do we match the fixed number of elements. So we have X, Y, Z match with the list. So this will be a match because list itself is 3 element list, and here X will be bound to 1, Y will be bound to 2, and Z will be bound to 3. On the other hand, if I say I have 2 element list on the left hand side as a pattern, and I want to match it to a 3 element list on the right hand side, this will result in a match error. Similarly, if we have an empty list on the left hand side and non-empty list on the right hand side, this will also result in a match error. So this is the basic list pattern matching. But before we go, I want to note that you can go inside the structure of the list itself to bind values that are nested. What do I mean by that? So let's say you have a list of pairs, and here we are saying that we will take this list and look at the head, and if it is a pair of tuple, two values tuple, we'll take that and we're going to discard the tail, and let's say we want to match it to number 3 and 4, and then we have 5 and 6, and now we will have a match of the tuple on the left hand side. The first element is the head, which is this tuple 3 4, and we have nested our pattern to bind the first element of the tuple to the variable x, and then y will be bound to 4. So here x will be bound to 3 and variable y will be bound to 4. So as you can see, you can create arbitrary patterns to bind the variables to the elements of the lists that we want.